So which part of the paper do we write first? Which part of the paper do we write first? Don't take any notice of what's up here. Anybody got any ideas of what you might write first? Well, it's no surprise, it is the results section. Now, did you expect that? Is that what you thought I would say? Yes? No? No? Yeah, most people would say, I think, oh, you start with the introduction. Not true. I hope I can persuade you that you start with the results. So you and your co-authors or your supervisor need to decide when you're writing a paper or even writing your thesis which data should be included in the paper that you plan to write. You can already see that if you're going to exclude a lot of data, you'll probably exclude a lot of literature in your literature review. You will change how you're going to write the introduction. So in writing the paper, you need to decide what you're going to include and what you're going to exclude, leave out. You need to decide what the important points are that can be used to form a story, because you're going to tell a story in the paper that you're writing. And it's a story about the new information, the new discovery, the new results that you've got that nobody else has got. And you need to think about what are the main messages that you want to deliver from those results that you have. So think of it as a story that you're going to tell. Think of it as a story around that very original, very special data that you've spent a lot of time collecting. But which data are you going to use to tell that story? Not all the data you've collected. One of the really challenging things as a scientist is to know what to put aside. Even if it took a lot of study, a lot of work, a lot of energy, a lot of hours, a lot of weekends to collect, it still may not be worth publishing. So let it go. Focus on the data which you can use to tell the story. So think about the story, think about the data for that story, think about the evidence that you have to accept or reject a hypothesis, to prove or reject the aim that you have had of doing the research, to record that information that you've got that's really important to convince somebody that this is new and different from anything that's been published before. Remember what I said, you don't need to use all your data. It's the key data that help you tell the story, help to accept the hypothesis, help to show that something is really new and different. So not all data from your research are going to be included. You then need to think about how you're going to organize the results that you have. And typically you'll be using tables and figures. How you organize your data is quite critical, and we'll look at some examples of that shortly. But the tables and the figures should stand alone. What do I mean by stand alone? Somebody opens the journal and just sees your table number 1. Without reading anything else, they should be able to understand table 1. The information that is in that table and that is in the caption for that table or figure. It should stand alone. One of the reasons it needs to stand alone is that even though you might be writing in English, a lot of the people that read your paper won't have English as their first language and may only look at the tables and figures in your manuscript. So they need to stand alone. They need to be kept as simple as possible. Again, if they don't have English as their first language, making it complicated is difficult in getting the understanding across, and they must meet the journal style requirements. Don't go putting in a table layout that you think is great if you've never seen that in the journal that you want to publish in before. Meet the journal style requirements. Again, you need to just reflect on why we use tables and why we use figures. We typically use tables to record real numbers, real data that you don't need to extrapolate off a curve or figure out from a diagram. Real data. If you want to prove that this variety of mango produced 10 kilograms per hectare and this one only 8 kilograms per hectare, then a table is good to show those sorts of differences. Figures are not so good. Tables are good for showing the precision of the data. Typically you'll see more standard errors, more analysis of variance results on a table than you'll ever see in a figure. Tables can also be used to show components of data and how you calculated different things. So again, if I use the fruit example, number of fruit on the tree, average weight of fruit, total yield. Tables are good for showing those sorts of comparisons. And you can often compare, in that example, not only compare the components of yield, but perhaps compare 10 different cultivars. So tables are good for laying out those types of data. Whereas figures are useful for showing trends, curvilinear responses, linear responses, bell-shaped curves. They can represent a pattern of results, and they typically will only compare 2 or 3 things. If you think about it, most figures only have 2 or 3 lines on them, whereas a table might have 20 rows and maybe 6 columns. So figures can often be quite simple and show an overall pattern, whereas tables can show a lot of detail. Does that figure look pretty good? What do we think of that figure? Is that all right? Is that what you'd see in the journal? Yes? Nice curves, standard error bars. Not too bad? Yeah? No? What does days mean? Days from what? When I was born? Days from flowering? Days from harvest? Days from what? We don't know. We might find out if we read the caption, but we don't know. You may be too far away to see, but you've got the handouts. Can you see the standard errors where they break? You know which standard error is responsible to that point? Not really, they all overlap, they're all over the place. So can you tell what the differences are between the lines? Not really. What about the size of the symbols here compared with here? Quite difficult to see which is which. The triangles and the circles are too small to tell the difference. And to understand this line, I've got to go up here and back to here and down to here to try and figure it all out. So what looks like quite a good figure has a lot of problems. Not simple, quite complex. But here is what you might do to make it more straightforward. Suddenly we have one error bar. We probably need two, and well, we probably need a series across the bottom, but I've only put one in there for the moment. We now know it's days after fertilizer application. So we're spelling out exactly what that time scale is. And notice that the figure caption is about twice as long as it was before. And if I don't read the paper, I just look at the figure and read this, I get the story. Standalone. Standalone. We've also done some other things with that figure. We've got rid of the box. You can put a box around the figure if you like, but the journal will set the figure size depending on what the journal decides to do, not what you've done. And if you leave the box off the figure, it gives the journal more scope as to how they position and display your figure. We've smartened up the error bars, we've got a better axis label, and we've got a far more complete caption that tells the story for that standalone figure. Do we like this one better? Oh, by the way, because we've got rid of the box, we've also gone from 0 to 2 to 0 to 1.6, which has separated our lines out more and enabled us to tell the story better, to display the trends better. Now, if this was mine, I'd also have increased the size of the symbols on the lines so that they stand out much more clearly. So we have a lot of choices when we design figures for our data. And if you finish up with one that looks like this, ask yourself the question as to whether it's too busy, too cluttered, whether it's clear enough. And if it's not, perhaps say to the person in your lab or say to your supervisor, look, I'm worried about this. It's not getting the message across clearly. What do you think we can do to improve it? And have a conversation around that point. Any comments, any discussion? Do we like this one better? Yes?
I have a question on the region that you put the symbol on.
Yes, down here.
Yes.
Yes. That's why I would have made these a bit bigger. But anyway, aside from that, yes.
Okay, this is a what do you call it? A normal that we can do that.
Yes, you can put symbols in a caption. That's not a problem. Microsoft Word will allow the inclusion of symbols in a text line. So there's no reason not to do it. I agree that this is probably more typical because, again, Microsoft Word allows you to put a text box in and display that. But think about it. You've got to go from the text box to the line to the caption to put the story together. Whereas here, at least, you've only got to look at the caption and the graph to understand the story. One less step, a lot clearer to do it that way. But I agree, a lot of journals don't seem to put symbols in the caption. There's no reason why they shouldn't. Any other comments? All right, so let's then have a look at a table. Here we have a table with 8 soils. A clay something, a clay content, a silt content, milligrams of potassium in the soil with a WS, I don't know what that means. Calcium chloride I know, and I don't know what sodium NTP, sodium TPB means. And we've got a caption which said soil test potassium and mineralogy of soils, SDs equals standard deviation. Does it tell a story? Does it present a picture? Is it clear? Is it standalone? I think everybody has said no. So what do? Again, we do some simple things. We have a much bigger caption. I now know that WS means water soluble. I now know that sodium TPB means sodium tetraphenyl boron. That's fine. But look at what's happened to the soils. They're no longer ranked 1 to 8. 1 to 8 might have been the way you labelled them in your thesis work. But it doesn't matter. 1 to 8 just happened to be convenient for you to call soil 1, 1, soil number 8, number 8. What is important is this goes from a small number to a big number, small number to a big number, small number to a big number, small number to a big number. What am I starting to see? A trend. That all of these values are going up, going up, going up, going up. So they probably are interrelated in a very positive way. So how we've listed this originally was very unhelpful. Now we can start to understand what it was amongst those 8 soils that caused these results to be the way they were. So we've organised the data. We've put in a decent sized caption which is much more self-contained. We have got rid of decimal places. I don't know what it is about human nature, but when we see a computer printout that has 4 decimal places, we want to put that into our table. But did we measure to 4 decimal places in our analysis? No. We measured to whole numbers. So if we've got a mean or a standard error, we should be citing whole numbers. We should only cite to the measurement precision that we used, in spite of what the computer has told us. The computer will print out 50 decimal places if you ask it to, but you never measured to that degree of precision, and you shouldn't be claiming that. So we've got rid of the decimal places, we've ranked the soils, we've got a better caption in there, we've got a self-contained story. Alright, so we've said soil texture correlates with potassium concentration determined in 3 different ways. Self-contained. Does that make a lot of sense to you? So think about those tables and those figures that you're putting together from your research. How can you make them stand alone? How can you make them easier for the reader to understand them? You cannot make somebody read your paper. If I'd have looked at this table, I probably would have given up. If I look at this table, I get really interested and excited and I keep reading. This one stops me, turns me off. This one makes me excited. All because we've simply changed our layout. So you need to think about that. And this one is part of the story that we're trying to tell. Remember, the result's about telling a story. Any questions about the table?
The abbreviation, most of the time I saw it, they're pleasant under the table.
Yeah. It's not a problem to put some of this information as a footnote to the table. That's fine. Still standalone, still quite clear. Not a problem. Whatever is best. I actually think this is fine. I don't think that's too cluttered, too busy. If you've got a footnote, you've got to put a code in next to the number that refers to the footnote. It just gets complicated where perhaps it doesn't need to be. But by all means use footnotes to tables, not a problem. You would typically, for example, in this case, put the standard deviation as a footnote. with a little subscript on this number showing that that's what you have done. Other questions? So often we see that the wrong figure is used to present the data, that the captions are very weak, they don't tell the story sufficiently for you to understand what the figure or the table are about. You should not put the same data in the table that you then have in a figure. So that table that we showed with the soil potassium levels, we could have drawn that as a series of lines or correlated factors. That's fine. Decide whether you're going to do it as a figure or if you're going to do it as a table, but don't do it both ways. Don't do it both ways. It's either in the figure or it's in the table. And then don't repeat those same numbers in the text. That's very frustrating, to read the text and find out that all the author is doing is describing the same numbers that are already in the table for you to see. So you shouldn't do that. Refer to the table, but don't repeat all the numbers. We've seen that the size of symbols was not adequate in the example I gave you, quite deliberately. I wanted to make them small so you would be confused. That's a classic mistake. If you're going to use triangles and circles and squares, make sure they're big enough so when the journal prints your figure, shrinks it down in size, that the symbols are still able to be seen. We saw what would happen if you made the figure too busy, too cluttered, too much information. Remember the standard error bars, where one LSD bar under each set of dots would have been sufficient. The axis, the days, not clear days from what. So make sure you're thinking about those issues when you're drawing your figures. I don't care what convention is. A lot of graphs will just have time, brackets, days, or just days. That might be all right, but it's not good enough if you want people to understand your results. Axes not adequately labelled, we've covered that. Not sure why I got that. There's quite a good use of a figure. A lot of data. It doesn't matter, this is a component analysis with factor 1 and factor 2. But clearly they fell into 4 groups. And big ellipses around each group of figures shows that to the reader, that clearly Group 1A was a very separate population than Group 1B, Group 2B and Group 2A. That's quite a nice figure, tells a broad story, huge amount of data in there. Look at all the poor data points, massive amount of data, but breaks it down in a way which is easy for the reader to understand. So a lot of figures are like that. They are a diagram that gets across a broad message. Here's a poor use of a figure. Again, it doesn't matter what the study is. It happens to be upper leaves and lower leaves and time after treatment and various levels of chlorophyll. But what was interesting was that the paper that this came from, there were 7 of these in the paper. 7 of them. Now if you're paying page charges, which you will be when you publish, 7 diagrams like that in a journal is about 3 journal pages. That's several hundred American dollars that you're paying for those 7 tables. Whereas you can reduce that down, 7 histograms, you can reduce that down to a simple table. Obviously there would be more repeats of that table to maybe 1 journal page, or definitely 1 journal page. If we go back again, This is very simple. High, low, high, low, high, low, high, low, high, low, high, low. Do you really need a figure to show that? Typically, numbers here that are twice that number, twice that number. So you don't need a figure, certainly not 7 figures, to show the same sorts of simple data. You're paying a lot to have that in your journal article. So go to a table. If you can simplify it, the reader can still follow those patterns. The twofold differences are obvious and easy to follow. So common mistakes with tables, I think we've already covered some of these. Weak descriptive captions. Sometimes people put too much data into tables. If you've got something that fills a whole journal page and it's many, many rows long and many columns wide, think about breaking it up. You've probably got too much into one table. And if you don't need to put all the data in, don't put it in. Simply put in the text that data are not presented. If they're not that important, say so in the text. No differences were found amongst the treatments involving nitrogen and potassium, brackets, data not presented. That's perfectly legitimate. But don't clutter up the table if the data are not helping you tell the story. I've already said, don't believe the computer printouts. If you've measured to 1 decimal place, don't put 4 decimal places in your results. That's from the computer, not from you. Try not to put missing data in a table. If you've got missing data, it's better to describe that in the text. Poor arrangement of data in the table, we saw that with the soil test result. Think about how you organise the data in the table to help you tell the story. If you collected things a certain way in your thesis, in your lab work, that doesn't matter. Reorganise it so that it's ranked in terms of the results that you achieve. Alright, so we've talked a fair bit about organising the data and using that in clear tables and figures to help you tell the story that you want to tell. Now you have to put some text, some words around that. Yes?
Before going to the text, I think PPP suggests our students, sometimes they have the data, but they really know, like, for example, the figures. Figures you can make like the data and the line, the column, or even though like circle, right? And then if you have suggestion, like what kind of data should be used line, what kind of data should be used column. Because we have the problem. Actually, like if our research, right, we have to check the results every 7 days up to 28 days. But the student make the column.
The question that was being asked is, if you're collecting data, say every 7 days, might be a storage trial, you're measuring fruit softness every 7 days for 28 days. Should you plot a line or should you plot histograms or columns? Let me answer that 2 or 3 different ways. First of all, you should not draw a line if the data are not continuous. In other words, if I used a different population of fruit each time to get my data point, I should probably draw histograms and not join the points. But if I went back to the same population and measured it every 7 days, then I'm allowed to connect the points and draw a continuous line because I'm sampling from the same population each time. Now in most cases you will be sampling from the same population, I think.
Maybe the same population, maybe the number of repeatable sample, but the sample is different in each time.
Yeah, the sample is different each time, but you harvested the fruit from the same orchard or the same trees at the same time. So I think you would have a good reason to argue that you've got continuous data and therefore you can join the points. The second consideration is the story that you want to tell. That if you've got, I'm not sure I can do this, but we'll try.
เด็กๆจะถามภาษาไทยก็ได้นะคะ เดี๋ยวพวกคุณครูช่วยกันแปลและถ้าเป็นทางด้านสถาปัตย์ทางด้านวิศวะก็มีอาจารย์ช่วย technical term นะคะไม่ต้องกลัวค่ะอาจารย์ใจดีมากอาจารย์มีลูกศิษย์เด็กไทยเยอะค่ะแล้วก็อาจารย์สอนเด็กไทยเนี่ยอยู่ประมาณ30 คนสอนภาษาอังกฤษอยู่ที่นิวซีแลนด์โดยไม่คิดตังค์เพราะฉะนั้นแกจะคุ้นเคยกับสำเนียงไทยแล้วก็ไวยากรณ์ผิดถูกของเราเนี่ยค่ะ
You'll often, in the sorts of studies we're talking about, you'll be sampling, I don't know whether you can see this, but you'll be sampling every 7 days. One of your treatments might be, for example, that high CO2, high carbon dioxide, and the fruit will get softer over time. One might be, sorry, let's say that's high oxygen, low carbon dioxide, whereas we've got one that's high carbon dioxide and is suppressing softening. So we finish up with a line that's through here somewhere. Now I would in that case draw histograms because it's quite difficult it's very easy to fit a curve through that. It's quite difficult to fit a curve through this, particularly if there's a reason to expect that physiologically it might have a strange pattern. If in fact that was like this, then I might be inclined to draw two curves. And use the equations for those curves to prove that they were different. Where you've got histograms, you can only do comparisons, pairwise comparisons at each point. Where you've got curves, you can do a whole trend analysis with a quadratic or a curvilinear function on that curve. So it depends on what you're really trying to achieve. Personally, I don't think we fit enough, I don't think we do enough curve fitting. And I don't think we use the statistics around quadratics or cubics or linear curves as much as we could do to prove differences. The other thing that if you're doing histograms, you're only comparing the number at each point, whereas if we're fitting a curve, it's the number times the number of sample periods, sample intervals. So you've got a much greater sample number in your curve fitting than you have in your histogram comparison. But we're getting into stats, and that's not what we're really trying to do here. I think that's one step back in terms of understanding how to analyse and present your data. But has that helped? Maybe?
I think it's depends on
what we want to show.
Yes,
But
exactly.
they didn't know. Well, like sometimes I thought, oh, this is very good. Present, share.
Yeah, think about curve fitting where you want to get maximum return out of the number of data points that you've captured. And if you're trying to show, like we have there, patterns of one treatment deviating from another treatment. By the way, you might still fit linear regressions through there. You should use the stats package to tell you which curve is the best fit. Alright, so the results section, if you have a look at most papers, the results, the text of the results section are usually quite simple. They outline the most important findings. They refer to the figures and tables where the results can be found, but they don't repeat those results. And all figures and tables must be referred to in the text. So don't let me read the text. If you've got 5 tables, don't let me read the results section and find that you've only mentioned 4 figures. I need to see all 5 figures referred to. So all figures and tables must be referred to in the text so the reader knows where to find them. The results section should comment on but not discuss the results, unless it's a results and discussion section. Alright, so we've just got a results section, no discussion of the results, and typically use the past tense. Now this is where English gets difficult for you, but think of it this way. All of the results that you've got, that you're describing in the results section, were things that you did some time ago. So they were this and they were that. They're in the past. So think about that. The results section will always be written in the past tense. Very simple message. Very simple if you understand that. So, hydrochloric acid was used to develop the results presented in Table 2. No significant differences were observed. Values were recorded. Dates ranged from. Temperatures were cooler. But where you will see present tense in the results is where you refer to a table or a figure. So the results or the effect is summarized in Table 1. The result from this experiment is shown in Table 3. Where you've got a text that relates to the results past tense, often where you're referring to where to find information in a figure or a table is present tense. Read enough papers and that'll become quite clear to you. So, in summary, select the best data, or select the data which best illustrates proof or rejection of the hypothesis that you set out in your introduction, or that you will set out in your introduction. Putting that simply, select the data which best enables you to tell the story that you want to tell. It's hard to do, but put aside all of the other data that you don't need to tell that story. Hard to do because it's all your hard work. But if it's not going to help tell the story, put it aside. Carry out the appropriate statistical analysis. I don't want to see something in a table that later when I read the materials and methods is not supported by the way in which you did that method in the results section. So make sure you carry out the appropriate statistical analysis. Display your data in the most helpful and efficient ways in either tables or figures. We've seen how to do that. Write a text that describes but does not repeat the numbers shown in tables and figures. 99% of the time, don't repeat in the text the numbers that you've got in tables. Sometimes in a figure you might put a number in if the absolute number is not clear on the figure. You might put that in the text. But that's quite rare.
So it means that we should explain like a quantity, like a report as a quality, not quantity, not the number.
That's right. I think we're through. Just double check.
Most of Thai people repeat the number.
Just want to make sure I haven't lost you. So the point was that many Thai people repeat the numbers in the text that you're showing in the tables or figures. Please don't do that. It's just frustrating because when you're reading the text, you think that the author is telling you something new. So you think, wait a minute, I've just been looking at figure 2. I thought I saw that number in figure 2, and sure enough it is there. I don't need to read that again in the text.
Can you say something like, it is noted that, that the something is the highest at this number, like that.
That's different. That's different. That's fine.